Lesson 8 was looks like it's a review, and then lesson 9 is a different lesson. So let's, I guess, jump in.
The quiz is 31 item.
Okay, on lesson 8.
Oops, I think I'm on lesson 9 right now. Hey Sam, did you take your exam yet? Econ?
Not yet, no.
Oh, I have a trouble with my password today. With my proctor, the proctor is trying to put in a password. It wouldn't go in.
Oh, you mean for econ?
Uh-huh.
Oh. Yikes.
Yeah, and I emailed our instructor and haven't emailed me back. So.
You know, I had that happen with one of mine, but what happened is they had redone the they sent the proctor out a list and then they resent it out a second time with new passwords. So I wonder if that maybe happened to yours as well.
Okay, let me. Yes, and my proctor is our because I live in a little town and there's the whatchamacallit, my Relief Society president, and we go to the ward building and take it there. And I was just like, oh, it didn't work. So we called the office. They tried it and didn't work either. So
I didn't read this. I guess I missed this instruction here. It says we should have already taken this quiz first. And then we're supposed to take the second. And then the second time as a group. I didn't take it beforehand.
I didn't.
Well, I was working on it. I was working on it earlier, but I have not submitted it.
So oops. So sorry I did not do this earlier.
Yeah, I didn't notice either.
I don't think it should make a difference, honestly. So I think it should be fine.
So meet with your group, complete this quiz with
So let's go through it together. So which of the following variables are categorical? And if I remember correctly, categorical is things that we can count.
Well, you can still, hold on. The number 1 you can still mark true because it says, mark this false when you take the quiz alone for the first time. So.
But we're not alone, so just put true.
Yeah.
Okay,
so,
go ahead. Sorry.
Oh, you want to mute yourself again?
Oh, sorry.
Sorry. You're all right. Okay, so categorical, and if you remember that, if I remember right, that is things that counted and that matter. If you add 1 or subtract 1, it actually matters. So I would think the animals in the zoo would be 1, right?
Wait, was categorical when you can count or the one you can't count?
Am I thinking
count? It's like it's a random thing usually, so I think it's only a random, like the brand of toothpaste at a convention store.
Oh, that's right. The numerical. I was thinking numerical, right? I was backwards. Yeah. Okay, you're right. So it's just the middle one then, right?
Yeah.
I think so.
Because you can only select 1.
No, I think you can choose. Yeah, so you can choose more than 1.
Yeah,
yeah.
You can select multiple, but I think it's only 1.
Yeah, I agree. You guys are numerical. I was thinking numerical instead of categorical. Okay, the mean IQ test score in the United States is 100. 20 randomly selected statistics. Real quick, by the way, I was watching one of the reviews that he posted on the front page. And I remember we were asking, like, what's the threshold?
30.
It's 30, yeah. I don't know where that came from, but I saw that in the video. So anyway.
Yeah, I was like, oh, okay.
Right? That was the question we had when we said, what exactly is a large amount? Well, apparently it's 30 or more. So
I would think though that would depend like on what you're talking about, but I don't.
Right. Well, yeah, right. Like what we said before. Like if we're talking about the United States of America, 30 is a pretty small number. But if you're talking about, people in the 3rd grade class at school, 30 sounds like a lot. Anyway, so.
Well, not in the Philippines.
Not in the Philippines.
One class could go to 30 to 40.
Yeah.
Yeah.
So
let's see. So the mean is 100. They take 20 students took an IQ test and the mean of their score is 112. Which of the following is true? So is the 100 a parameter or 112 a parameter, or is 100 or 112 a statistic? And we can check more than one.
100 is a parameter and 112 statistic.
Statistics, yes.
That's what I thought too. Everyone good with that? Thumbs up. All right. Let's see. 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. Let's see, what's the question at the end? What type of sample should we collect from the residents, or gauge the residents' responses? So a simple random sample, a systematic sample, a cluster sample, or stratified sample.
Stratified is divides data into similar group, and sample random SRS is taken from each group. That's what a stratified is. And cluster is all item in one or more randomly selected clusters or blocks.
So wouldn't a simple random sample probably be the best, because then you get random, you get ideas from each location? Or did you say
there's 2 locations that you're trying to pull data from, isn't it?
The simple random sample might not give you from each. I mean, you could randomly get all in one area.
Mm-hmm.
Okay, so what's the one that, is there one that picks from every individual place though?
It's
yeah.
cluster
I think it's
sampling.
stratified.
Stratified or cluster? Do we need to go look back at the notes?
Okay, stratified, you can get you divide the data into a similar group, and sample
taken from each
random
group.
sample, yeah, is taken from each group.
So I think that sounds the right one, right? Is because we want each group,
and then you get a simple random sample from it.
We essentially want a handful of people from each of the 4 distinct neighborhoods, right? Is that more with the stratified? So what does the cluster one say?
It says it's all items in one or more randomly selected clusters. So it could be in just one cluster, or it could be separated. So I guess it kind of depends.
What you want. What you want to get. But it's here, it says property taxes are usually roughly proportional to the property values. So
right, but it's asking what the residents' responses to a property tax increase. So you kind of want to know what, I mean, somebody in a low value might have a different opinion than a high value, right? So I still think whatever gives you the best sample from the most places, which
it should be well,
if I remember this right and correct, so SRS is, like you said, just randomly picking out of a hat. A systematic is that one where you say, okay, we're going to randomly pick like a number, and then we'll pick the 7th one out of the hat, and then we pick every 6th one after that. And then a cluster we talked about is either picking like one neighborhood and grabbing a bunch out of it, or it's at all neighborhoods. And then but a stratified is where it picks some from every distinct group.
Variation from one to another.
Well, if you wanted to, go ahead.
So I opened the actual lesson when we were learning about these. And on the cluster, it says that when the variation from one block to another is relatively low compared to the variation within the block, cluster sampling is a reasonable way. But if they differ, I think you want more of the stratified.
Which it says that they're 4 distinct neighborhoods, so they are very different. So stratified then? Stratified?
I think so.
Yeah.
Okay. Save and go. Let's see, hold on. Which type of sampling scheme is implemented? So that's what our question is. So when designed experiments are conducted in a public school system, researchers typically choose a particular district. and randomly select teachers of, say, 4th grade students. So that's the experiment is then conducted using all the students in the selected class. So we were just talking about that, right?
That's a cluster.
That's a cluster.
Yeah, that's a cluster.
Yes.
Perfecto. At a school fundraiser, the name of every person who attended was entered in a drawing. At the end of the evening, 6 names were selected to receive the door prize. Which type of da-da-da-da?
Simple
Is that
random.
SRS?
Yeah,
Yeah.
it's a random sample.
What's a voluntary random response sample? Because isn't this it says that every person who attended an event? So don't they? The simple random would just be random people. This one, it's only people that have attended and were in the drawing. So isn't that a voluntary response sample?
Hold on.
I don't know if that was even in our.
It's not on the selection. There's only 5.
But do you remember that there was one that, like, you know, if you send out a
Convenience.
survey to someone and they respond, isn't that what that is?
There was a
that the
convenience
convenience?
sample.
Was it a convenience sample? Okay,
Mm-hmm.
that's what I was thinking of. So that does
The
not.
ones that are relatively easy to obtain. It's chosen by convenience without introducing any systematic bias.
Okay, so a voluntary response sample is not one of the ones we've even talked about.
I don't think so.
Oh.
Well, they took a list of registered
Yeah, I don't even.
Democrats and Republicans, and then they selected a simple random from that list. So they get the Democrats and Republicans. You have two things that they took a sample out of it. A simple random sampling, and they want to get their decision from those samples that they got. So it's similar to stratified.
I'm just curious. I think you guys are right, but in survey sampling, volunteer response bias occurs when sample members are self-selected volunteers. An example would be call-in radio show that solicits audience participation in surveys. See, this is where I think it's that voluntary thing, because it says compared to a random sample, these types of samples are always biased. For example, people call in a radio show. So, like, this is a biased sampling because it's only these people who were at the school fundraiser.
Yeah.
Does that make sense? Like, that's I guess what throws me off is that they're only doing they're doing people that happen to go to the school fundraiser. They're not randomly sampled.
Okay, what number are you working on?
Number 6.
Oh, I thought we're in number 7. Sorry.
I was wondering. I was like, "What are you talking about? Republicans?"
Well, isn't it number 6 a simple random sample?
Well, that's what I'm saying that I don't think it is. I think it might be a voluntary response sample.
I think it still might be random because there's tons of different things that you go to. Like, you can go to a grocery store and take a survey and something, but because you're not at a grocery store, you're still not a volunteer taking it. Mm-hmm. You're still just a random person.
It's just like a draw from the hat, you know.
So I think that the people that attended the drawing, attended the fundraiser, they all voluntarily went to the fundraiser, but I think that the people there are the population.
Mm-hmm.
And then the sample isn't the people that showed up, but the sample are the 6 names that were randomly selected.
Mm-hmm. But it's randomly selected from the people that's in the fundraiser. So it's from like all the names that's in there, like a class name, you put it in there. It's like
I will bow to the majority here. So we'll go with SRS. So number 7.
I thought you move on to number 7. Sorry.
You're okay. So now we're talking about they wanted essentially a special interest group about wolves. So to adequately gauge both sides, they're going to essentially look at registered Democrats and then take 100 of them, random 100 of them, and then take a look at the Republicans, take a random 100 of them. Which type of scheme is this? We talked about, is that a cluster again?
Stratified.
I think that might be
or is that a stratified?
Yeah, I think probably stratified.
Because you got two groups and you pull whatchamacallit, a random sample.
Si quieres, después salimos.
Yep, divides the population into separate groups called strata. Then a probability sample, often random samples drawn from each group. That sounds exactly right. Okay. A survey was taken of purchases on the crossroads. Open the data file and use this data to answer the next 3 questions. Okay, so I'm going to open this file.
4.771.
It just says, what's the mean? Is that what it's saying?
Mm-hmm.
Yeah. That's what I got, 4.771.
Oops. That shortcut doesn't work on the Mac the same way. Yep, 4.771. I concur.
Next
Standard deviation
is 1.912.
Yep.
1.92. Finally, start by creating a histogram of the amount spent at the crossroads purchase. Then mark the following statement as true or false. I created a histogram representing the amount spent in the crossroad purchases.
I created one.
So when they want us to do a histogram, you're just doing that inside. You're just doing that inside of Excel.
Yeah. It didn't say what kind of what type of histogram that.
That's what I wanted to do. Do you just make a chart, or what? Do you typically
just
do,
select one of the option, because it didn't specify what type of graphic they wanted, so they just asked us to make histogram.
Just kind of curious which one would be the best one for this guy. Okay. True. Save. All right. Now we are on to question 11. There's a bunch of information above. And then the question is, what is the value of the number that goes in the position marked with an A in the table above? Wow, it's been a little while since we've done this kind of stuff, huh?
So the X with the thing on top, is that's the mean.
Yeah.
So you need to get the mean of all the temperature and deduct that from like 37.91.
Okay.
Yes.
Okay, so let me get the mean real quick.
So the mean is 38.075.
Did they give it to us, or did you already do it?
I already did it.
Perfect. It's on top.
Hold on. Yeah. Uh, 37.91 less.
38.075.
Hold on. Why am I not getting it right? Hold on. Is this there?
I got so it's a negative 0.165.
Mm-hmm.
Yeah, that's what I got.
That's what I got.
B.
So B would be, that one is this minus that squared. So this
Is that
to the second power. I got a 0.681.
Yeah.
okay?
That's just for those two questions, right?
The third one, that number 13, refer to that one.
So what quantity is equal to the sum of the numbers in the squared deviation column? Essentially, if we added this here, added them all up, what does it mean, I guess? Is that the mean? Is that the standard deviation? Is it the variance? Or none of those?
I want to say that was the variance, but I can't remember for sure.
What is the quantity is equals to the sum of the number of the square?
I mean, it's definitely not the other two. I think it's the one of the.
None of these is correct.
It's
None of this is correct.
None of these?
The standard deviation of the it's 0.715.
You're ahead of me. I hadn't gotten that far yet.
Oh, I thought we're at number 14.
Oh, no, that's where it was. We just haven't gotten to the answer yet.
Oh, okay.
Those variance or none of these is correct.
What's that?
Wait, I thought we were still on 13. Are we past 13?
I don't know. I thought everyone had said it was none of these is correct.
Okay, I didn't hear that. Sorry, my bad.
But I'm not comfortable on it, so I don't know.
So, are we on number 14 now?
Yeah, I got the same answer. I got 0.715.
Okay.
Me too.
Okay. 15 is false, right?
False, because standard deviation is 0 to 1.
Yeah, standard deviation can never be a negative number.
Yeah.
Okay.
It's getting more fun.
Oh, are these the same? Are these exactly the same numbers in the questions as the review?
Yeah.
Oh, then I just need to be looking at my answers.
Okay, number 16. Which location resulted in the most consistent temperature measurements from one seal to another? So wouldn't that be the extradural, whatever that is?
Yeah, because
it has the least deviation.
Yep.
Ask him. I think he didn't get it. I didn't see him going out there and. Sorry.
No worries.
Okay. So, The question is which allocation resulted in the most consistent temperature measurement from one seal to another?
That one was the extra dural.
Yeah, because there's at least difference.
Extra dural? The extra dural?
Yep.
Yeah, because there's a smallest standard deviation.
Uh-huh.
And then 17 is 8. Because that's the third quarter.
It's in between the 50th. Okay. 18 is
percentage
50.
18. What percentage of data lies between 4 hours and 8 hours?
That's 50%.
Isn't it that one rule?
No, this one's isn't it the.
It's a plot box. You called it. Box plot.
This is like the first quarter, second quarter.
Number 4 is the
quarter, last
25%.
Oh yeah.
Number 6 is 50%. We just had to write it down 50.
Let's see. Estimate the mean of the measured nitrate concentration in Rexford's drinking water.
That's a lot, guys. Sorry, my son is a lot now.
About 10 parts per million are considered health risk. Let's see. The city reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million. And values outside this range are unusual. We will assume that U equals 2, standard deviation equals 1.
So you get the mean of the 2?
Estimate the mean of the measured nitrate concentration.
Yeah, it's 2.055. Well, 2.055 because you add the two numbers, 1.59 and 2.52, and then you divide that by 2, giving you 2.0 or 2.055.
Yeah, I got the same number.
Yeah. So standard deviation.
Estimate the standard deviation of the measured nitrate concentrate.
How did I put in the right number in there? 159.252. That's why I'm wrong. Hold on. It's a 0.657 or 58 rounded. Rounded 3 decimal 658.
And we're getting that because we're taking our 2.055, essentially minus 2x equals 1.59 or 2.52, right? And solving for x, or the standard deviation.
I just did it in Excel.
Right, but what equation are you using?
I just did the standard deviation of the 2. So
you're just taking the standard deviation between 1.59 and 2.52?
Mm-hmm.
Is that what you're doing?
Yeah, that's what I did. I'm not sure if that's correct.
I don't think that's the right equation, though, right? Because that's just saying that that's where it can be between. Those aren't really.
Yep, but they didn't give. Wrong. But they didn't give any. Oh, about 10 ppm. Hold on. Did I miss that one?
Like I have like 0.233. If you punch in, let me just see something real quick.
So hold on.
Anybody else have any thoughts on this?
I don't have my equation, but on mine, the answer I had gotten was 0.465. I don't remember how I got there.
I'm currently trying to figure it out really quick. I think I almost got it.
This is where I get 0.233. This is my thought process here. Can you guys see what's showing up on your screen right now?
Our quiz.
Okay, so let me add this over here. Okay, do you see my Wolfram Alpha page now?
Yes.
So I'm punching in, we found the mean, but the equation is the mean minus 2, I put x just as a variable, but that's the standard deviation. That's what we're trying to solve. And we're given this 2.52, and it solves to 0.233. Or if we type in the other number, what was the other number? 1.59,
yeah.
That gives me the exact same number. Just putting in our, I think we solved for this, and then that's how we solve for our deviation.
Yeah, I think I didn't see. I was supposed to divide by 2. That's why I'm getting the 0.465 because it's in there in your Wolfram, but it's double. My number is double yours, which is why I'm wrong.
Oh, you forgot to divide. You forgot to divide by the 2.
Yeah.
Right. It's 2 to the deviations.
Okay, hold on.
So as long as this answer is right, then that makes this answer correct.
Okay, what's 0.233? Well, you guys have that applet.
Sorry, guys.
The coppers are coming for you. So is everybody happy with this then?
Yeah, I'm good with that.
Yeah, okay. Since you have the applet anyway.
Let's see. Between what two measured nitrate concentrations do approximately 68% of the data lie? So this is that, right, this is one standard deviation of 68%, right?
Yeah, one going both ways. One above, one below the mean.
Mm-hmm. So it's one.
We figured the means here.
Mm-hmm.
Right, so.
And the numbers they give us are 2 standard deviations, right?
So it should be 2.288 or somewhere in there. 2.288.
Yeah, the bottom one.
Last one, so it'll be D.
So that's reassuring. That means that it sounds like we have this number correct if one of these match our numbers. So that makes me feel better.
Oh yeah.
All right, last section, I think. Use the following information to answer the remaining questions. What is the probability that a randomly selected student will score above a 542.3 on the GMAT? So let's look at here. So our mean is 242.3. It has a standard deviation of 120.54. So if we think about that, we're just looking above the mean. So it should be anything over 50%, right? I mean,
50.
The mean is the average, right? So shouldn't that mean 50% of people should score above the mean?
Uh-huh.
0.5.
Uh-huh.
I mean, do we need to worry about like z-scores and all that stuff and putting that in, or is it as simple as just putting in 0.5?
I don't know how we could find a z-score because the number that they're giving us is the mean as well. So we wouldn't. It'd be 542.3 minus 542.3, and then we'd have a 0 in the numerator, and you can't do that.
That's a good thought. So it has to be 25. Okay. If you divide by 0, the universe will explode. What is the probability that a randomly selected signal score below 600 on the GMAT?
So
that's above. So 600 is above the mean. So that means we should have a positive number, but we're looking to the left.
6840.
I'm trying to go with that little explanation he had. That was actually pretty helpful, that video.
Yeah.
So we need to find the z-score of 600. If somebody could do that, I'll pop it in the probability.
Okay. 600 minus 2.3. Oops.
Divided by 120.54. It's 0.478. Hold on. 0.4.
120.54. 20.54.
0.4786. So
0.478 or 479.
Yeah, 0.479.
0.479. Yes.
Okay, and then we're going everything below that number, so it should be this middle and this side, right?
Correct.
So what's it being asked? Below 600, yeah.
Yeah, so 0.684.
Yeah.
I'm sort of starting to understand how to use these tools.
So above 600, or 600 or above, so we can keep the z-scores the same, right?
Yep.
Uh-huh.
Yeah, it would be the difference instead of 316, yeah.
That was nice of him to keep that the same. Find the GMAT score that will correspond to the 10th percentile.
So
I don't remember how this one works.
You need to put 0.1 up in the probability on the applet, and it'll give us our z-score.
Say it again, 0.1?
0.1, yeah, up in the
area?
probability. And that gives us our z-score. We plug that into the formula.
1.282.
So it's 1.282 equals 1.282 equals the variable minus 542.3 divided by 120.54.
Okay, let's go back to the Wolf. I love Wolfram Alpha, by the way. 1.282. So it's 1.282 equals
minus
variable.
So then it's up on top, right? So it's x minus what's the
542, I think 542.3, I think.
Divided by 120.54.
0.54? Like that?
I think so. Yes.
120.54.
So x equals 696.8. So he said rounded the whole number, right? So 697. Did it say the whole number?
Yeah, it says whole number.
So does that? Let's look at it like.
So is that the answer for the 10th percentile?
No, that sounds like
It's too big for the 10th percentile, isn't it?
That sounds way too high for the
10th percentile.
You know, it should have been on this side, huh?
Yeah, I think
like that.
When I was looking at it, I think it was like 388 or something like that.
So 0.0999. So let me just change this here. So this just
yeah. We need to take the negative z-score, not the positive.
The negative one or the?
We took the wrong z-score.
No, it's not. Well, it wasn't the z-score. We weren't grabbing the z-score. I thought we were grabbing this thing. No,
well, that's where we put in the 10th percentile, and then we take the negative z-score.
Okay, sorry. So it's negative, what is it again?
282.
How does 388 sound?
Sounds brilliant.
That sounds better.
Yeah, 388.
And so the 90th percentile will be 697.
Yeah.
I was just doing that 26 first, you know. Find the first quartile of the distribution of GMAT scores.
First quartile.
So that's the 25th percent, right? I mean, we could technically do this again, right?
So you can do
0.25.
0.2. And then we want the negative z-score.
And then it's the same. It's still the same
equation.
Deal, right? Equation.
Can we use that thing that you're using right now for exam?
It's just a fancy calculator, Wolfram Alpha. Really, I don't know. I mean, it's essentially like it's like Excel. It's just I don't know.
How can you download that?
You have to pay for it to download it.
Mm-hmm.
But it's just a website, Wolfram Alpha.
Okay.
It's fantastic. They do have an app, but like their full version. So you like to do like step-by-step solutions. That's their paid. That's their paid thing. If you really want them to walk you through how they got there. So 461 is the first quartile, right? Did I do that math right there?
Yeah.
Yeah.
It sounds
That's
right.
what I got.
That's what I got too.
And then the third quartile.
6 to 4.
75. But that should be the positive side this time, right?
Yeah.
So it should be this. Just on the positive side with that, but well. 624. You guys already said that, I think.
Mm-hmm.
Consider a simple random sample of 15 students. What is the mean of the distribution of the sample means scores for all such samples? This is that one where you have the square root of 15 on the bottom, right?
Yeah, it's the central tendency thingy. The formula, whatchamacallit, x minus
quit getting so technical on us.
over standard deviation divided by square root of the sample.
Right.
So x6.
Is anybody rolling that out right now?
Divided by the 15th. 15, oops, square root is 3.872.
I told Julie I thought that gal was a flake and not a great candidate.
For who?
For sped. Remember me saying that over and over? I thought, she hasn't turned her app in, she's kind of flaky. I guess who quit after day one.
Anyone have any luck?
Hold on just a sec. And the question is, to the nearest decimal. 5, 4, 2, 3.
So isn't the mean just the mean we already have?
What was the question again?
The first one is just the mean of the randoms of the sample, and then the next one's the standard deviation, and that one uses the square root.
The mean of the sample means is u.
So isn't that just the mean?
That's what it says right here.
And then the next one uses a standard deviation over the square root of the number.
Okay.
So wouldn't it just be the mean we already have?
Yeah. Which is what again? 542.3.
Yeah. I could be wrong, but that's what it seems.
Well, if you look at mine on lesson 6, I'm looking at it right here. That's what that says right there, right?
Yeah, that's what I think it's saying.
Yeah, it is.
The mean of the sample means is U.
So it should be 542.3.
Yep, and the standard deviation of the sample means is the standard deviation over the square root of n,
which is 15, square root of 15.
What is the sample mean?
What
is this? I'm sorry. What's the standard deviation?
120.54
divided by the square root of
15.
How do I do square root again?
15 square root 3.87. Okay. 120.54 divided by.
I can't remember how to do a square root thing.
31.12? 31.1232? 123?
Yeah, 31.123.
Mm-hmm. Did you get the same one?
That's what I got too.
It's 31.123.
Mm-hmm.
Yeah.
Okay.
So you like for his example, he always get the square root first, then he divide whatever needs to be divided on the square root. So
yeah. What is the probability the sample mean of the GMAT score for the random sample of 15 students be greater than 600? And this is where we go into this bigger equation.
What's sullen?
Right, where it's like, oh, where should it go?
Sample probability. Or 2.
Right, we have to find the z-scores and then put it over, don't we, or something like that? And put it in the probability deal.
Yeah, I just don't remember.
Trying to find that.
Was it less than 7?
It was. That's what I thought, but then I didn't see it. I'm looking through it right now. Standard deviation of the random variable. Here it is. This is what we're looking for right here. So it's
value minus mean.
It's the value minus the mean.
Okay, over
the standard deviation divided by the square root of n.
Okay. And what was the number they gave us?
Z-score, and then tell me the z-score, and we're looking for that they'll do greater than, so.
So it's the z-score.
37.7. And
it's the z-score is 1.854 with that equation that we have.
So that would be the probability of 0.0319 or 0.032. 3 decimals, 0.032.
So 0.032. Okay.
Or in other words, 3.2%.
Okay.
Right? That makes sense. Ready to submit? See what we do?
Seriously, our instructor in econ have not emailed me back.
1, 1, 1, 1, 1, 1, 1. Bunch of ones.
Bunch of ones.
100%.
That's good looking. Good.
You guys are amazing.
Well, thanks for your brains too.
You guys rock. Now we get to go on to the next lesson. Everyone ready for lesson 9?
Heck yeah.
Heck yes.
So we can get done with this and.
Kind of excited not to have another meeting. Not that I don't want to see you guys again, but
no, I have a lot of meetings that I have to bunch in 3 days.
Exactly. All right, let's look at group meeting 9. This one was kind of interesting with the whatchamacallit, like the errors and the. This one seems a little easier.
It's.
Okay, which hypothesis involves equality? The null hypothesis, the alternative hypothesis, or the true hypothesis? It's the null hypothesis, isn't it?
Equality is null, yeah.
Mm-hmm.
The p-value is the probability of obtaining a simple statistic at least as extreme as the one that was actually observed. Remember that the p-value is the that's what they just said. When computing the p-value, which hypothesis do you assume to be true? The null hypothesis or the alternative hypothesis?
Still null, right?
Null, yeah.
Hypothesis.
That's the status quo. Suppose that the null hypothesis is that the mean equals 10. Which of the following represents the alternative hypothesis for a two-tailed test?
The not equal to 10.
That's this, right? Yep. Because that means it can go above or below. So there's your two tails. And this doesn't make sense because that's saying that it's the thing and then da-da-da. Very good. Which of the following represents the left-tailed test? So that would be less than?
I was thinking less than, but I don't remember for sure.
Hold on, let's see.
Let's look. I think it's less than, but let's double check.
With alternative, it would be less than, so it would be A.
Right, it's which way the carrot's pointing kind of a thing.
Yeah. It's.
Okay. And then so that way the right one is going to be B. Make sure they didn't switch it on us. Which relationship would result in failing to reject the null hypothesis? Okay, let's see here. Remember that we determined the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha.
Failing is if it is the value is the alpha is the value is less than what you call it.
It's the second one, right?
I
can't remember.
I don't know. I don't remember.
The number is lower.
Less than alpha?
Less than alpha or the p-value. Hold on.
We're in lesson 9, right?
Yeah. Go to the 4.3. So it's going to be down below that, I think.
Straight tail, left tail, large p-value, small p-value. Here we go. Level of significance, alpha. How do we decide if the p-value is small enough to reject?
So if it's less than alpha, that makes it rejects the. So the answer is greater than alpha, right?
The higher fail to reject is if the number is higher than.
So then it's the greater than alpha.
Okay.
If the P is low, reject the null. That's what it says. If the P is low, reject the null.
Mm-hmm.
And if it's greater, then you fail to reject the null. So it's the first one, right?
Let's see. If the p-value is less than a, we reject the null hypothesis. If the p-value is greater than a, we fail to reject the null hypothesis.
Yeah. So the first one.
If p is less than a, no, if p is less than a, so that would be the second one.
But the question is failing to reject the null.
Oh, there's that trick question thing. Thank you.
Yeah, I mean, yeah.
Like what backwards way to say something? Failing to reject. You know?
It's like a double negative.
Yeah. Okay. Thank you. Which relationship would you result in rejecting? Which would be p is less than.
Yeah.
Okay. Get more confused. Holy cow! There's 21 of these. All right.
Yeah, we're gonna be seeing more of these things.
Let's see. An insurance company is reviewing its current policy rates. Originally, the rates for the average claim was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate alternative hypothesis? The average claim amount is
greater than
$1,500.
Yeah. So we see.
Which of the following would be appropriate null hypothesis? The average claim is equal to 1,500.
Yeah.
The insurance company randomly selects 40 claims and calculates the sample mean of X is 1650. Use this information to answer the next three questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes.
Because the sample is more than 30.
The sample size is large.
Bigger.
Where 30 comes from, I don't know, but you know.
Teacher said it, I believe it. Let's see. What theorem or law justifies your answer to the previous question? The law of large numbers or the central limit theorem?
I was thinking
central limit.
Yes.
The larger sample.
Yeah, I was thinking central as well.
Which of the following is the test statistic as defined in this lesson?
Okay, I don't remember that one.
Test of statistics. Let's go look.
4.2.
Is it the X?
The z-score determine the x is far from the. This is called the test z, where z is the test to z, whatever it is, z.
Yeah. Okay.
Okay.
The historic mean of sales and receipts of grocery stores is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up this hypothesis test. Yeah, because she's writing out these grocery store person's going to be writing equations like this.
Everyone's got time for this.
Right? She will use the level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales for $144. What is the z-score associated with this test? Wow. Okay.
So we have
36 sales.
X is 144.
144, and the mean was before was 150. Does that matter?
150 divided by what's the standard deviation? Hold on.
The standard deviation is 40.
40.
And what's the formula we need to use on that one? Divided by the sample mean, the sample population, which is
36.
36. the square root of that. So 36 is 6. 40 divided by 6, that's 6.6.
Hang on one second.
144 less 150 divided by 6.6. Negative 0.9.
I believe you.
0.9. Wait, I was about to say.
So give it 0. Point, what did you say it was? 0. Point?
0.9.
Negative 0.9.
Okay, so the z-score, should it be negative? Yeah, because it's under the 150. So yeah, it looks good.
So 900 then, because it says round to 3 decimal places.
Oh, good catch.
Okay.
What is the p-value associated with the z-score from the previous question?
So how do we get the p-value?
P-value is the probability of attaining this test statistic. So we're going back to this guy. So what was it again? It was a negative
0.900, yeah. And
Okay.
we need to put that, where's the split area?
And what are we gauging though? Are we going, we want what's
0.
below it?
So we need what?
So I guess the p-value is that's what's above it or below it, or what is that going to go?
Let's see. So if the positive, like in the book, is 6.6685, so the area is above it. Hold on. It's on. Let's see. Keep looking down.
I guess it depends. Is it right-tailed, left-tailed, or two-tailed? But we're not sure what it's looking for. Like, what kind of test are we looking at right now? It's left-tailed, right? Because it's looking for a less than?
The p-value is the both sides.
No, but we're looking for left-tailed, so it should be this point.
Is it 0.3681?
No, this is the probability number.
Hold on, let's see.
And we're doing a left-tailed test because the person thinks it's less than. Right, so that's a left-tailed test. So if you look at my shared window right now, that's a left-tailed test. So it should be a 0.184.
0.184. Okay.
0.184.
2.184.
What inference would you make about the null hypothesis for this problem? Reject it or fail to reject it?
I think reject the null hypothesis.
The null hypothesis. Because it's lower, isn't it?
Right, but doesn't it have, what was the thing? It has to be a certain amount lower, doesn't it?
I think when it's just not
what we're saying
the
p-value has to be less than the alpha. So let's look at it. So our alpha is 0.05, and we're not less than that. We're more than that.
0.18. So then.
So our p-value is more than alpha, so we actually fail to reject the null hypothesis. Right?
Uh-huh.
Yeah, I agree.
Okay. So what is your conclusion for the problem? We have insufficient evidence that the true population mean is 150. We have insufficient evidence that the true population is less than, right?
Yeah.
So it'd be the third one.
Yep. Okay, number 19.
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I'm looking at. I had that out here a second.
That one I think is the type 1.
Yeah, type 1.
Okay. Last two questions. A researcher decides that instead of using a level of significance of alpha as 0.05, he will use 0.01. Which of the following will be true? The probability of type A1 errors will increase, 2 will increase, the probability that the null hypothesis is true will decrease, his experiment will be more scientifically valid. I think the last one's definitely wrong.
I think it's the probability of type 2 error will increase.
Yeah, I think so too. One.
Okay. If compute the probability.
I don't know how to do this last one.
Yeah, either. Let's see. Let's look at the how to compute the probability.
If A equals 0.05, compute the probability of committing a type 1 error.
If it was 0.5, wouldn't it just stay as a 0.05, or would it change?
Oh. I don't know.
The most common value for alpha is 0.05. Is equal for 1/20th. So when the null hypothesis is true, there's only 1 in 20 chance that it will be rejected as the 0 point significance. Other common choices relevant to this. If committing a type 1 error is undesirable, why can't we use an alpha 0? This would be impossible to make a type 1 error. Actually, this would make it impossible to predict any. A type 1 error is...
So yeah, isn't it just the 0.05?
Yeah, I'll just do 0.05.
Yeah. Because it's 1/20, which is just the 0.05.
So we're saying 0.05. Let's check it out. %, again.
Sweet.
Wow. Thank you, guys.
Can we take a group test this way or exam this way too?
I like that idea.
Better, isn't it?
I wish.
Yeah.
All right, guys. Well, that was awesome. Thank you.
Thank
So
you.
I guess we won't say hi till next week, but maybe drop a chat in Google and let each other know how you did the exam if you want to.
Okay.
We'll see.
We'll see. Guys.
All right, guys. Have a good night.
Have a good night. Bye.
All right, bye.